Dear students, last week we discussed about empirical formula and its determination. Today we are going to discuss about molecular formula of a compound and its determination. So let's get started. Molecular formula of a compound is the chemical formula which represent the actual number of different types of atoms present in a molecule of the compound. Okay, for example, the molecular formula of benzene is C6H6. This indicates that one molecule of benzene is composed of 6 atoms of carbon and 6 atoms of hydrogen. Okay, you understand till here? Similarly, the molecular formula of glucose is C6H12O6, which tells us one molecule of glucose consists of 6 atoms of carbon, 12 atoms of hydrogen, and 6 atoms of oxygen. Okay, so what is the relation between empirical and molecular formula? So, the molecular formula of a compound is whole number multiple of its empirical formula. Thus, molecular formula is equal to n into empirical formula, where n is an integer, it is a whole number having 1, 2, 3, 4, etc. Okay, values. The value of n for a particular compound is given by. So, value of n is given by n is equal to molecular mass upon empirical formula mass. The empirical formula mass is the sum of atomic masses of all atoms present in the empirical formula of the compound. Okay, so for example, for benzene, the value of n can be obtained as follows. Okay, the empirical formula of benzene is CH. We already discussed in last week. Okay, hope you remember this how this empirical formula has come CH, while its molecular formula is C6H6. Therefore, empirical formula mass, what will be happen? 12 into 1 plus 1 into 1. Okay, carbon's value 12 atomic number and hydrogen 1, so it becomes 13 empirical formula. Then molecular mass will become 12 into 6. Here you can see 12 into 6 and 1 into 6. If you calculate it, it comes 78. So n is equal to what will be happen? 78 upon 13. Okay, molecular mass upon empirical formula mass, and you will be get 6. Therefore, for benzene, molecular formula is equal to 6 into empirical formula. So it's quite easy and you can easily calculate it. So how we can determine or determination of molecular formula? First, determination of empirical formula mass. The empirical formula mass is obtained by summing up the atomic masses of all the atoms present in the empirical formula. Determination of molecular mass. The molecular mass of the given compound is determined experimentally by a suitable method. An easier method is vapor density method, in which the vapor density of the compound is determined. Okay, it is related to molecular mass by the following relation. Molecular mass is equal to 2 into vapor density. We discussed about in first video of this chapter. Third is determination of value of n. So we already discussed here that n is equal to molecular mass upon empirical formula mass upon okay. Next, determination of molecular formula. Now the empirical formula of the given compound is multiplied with the value of n obtained in the above step. This gives the molecular formula of the given compound. Okay, so from example you will be clear that the molecular formula of an organic compound is C6H12O6. Find its empirical formula and the value of n. So the ratio, if you see here, ratio of CHO atoms in the given compound is 6, 12 and 6. Okay, till here clear? Then the simplest ratio will be CHO 1 to 1. Hence empirical formula of compound is CH2O. Molecular mass of the compound 12 into 6 plus 1 into 12, 16 into 6. Okay, they are just atomic number there, and you have to calculate according to their atomic atoms there. Okay, so it comes 180, and empirical formula of the compound 12 into 1 plus 1 into 2 into 16 into 1. Okay, cause is CHO. Okay, CH2O. So it comes 30. So what will be your answer is 6. Okay, empirical formula you will get the value of n is 6. Another example is there. An organic compound contains carbon is equal to 40%, hydrogen 6.67%. If the molecular mass of the compound is 30.026, find its empirical and molecular formula. Given carbon is equal to 12.1 and hydrogen 1.008 and oxygen 16.0. Okay, is there their actual atomic mass is there. Okay, so uh, if you last week also we calculate this empirical formula, today we have to calculate molecular formula also. So here elements given, okay, atomic mass and its percentage is 40. So relative number of moles will be 40 upon 12.01, 3.33, and simple mole ratio for calculating you have to till here. Okay, last week also we see that first you have to do this activity only. So then you for do hydrogen and then do for oxygen also, and minimum value will become 3.33. Okay, so you have to divide all the values with the minimum value 3.33, and you will be get the ratio 1, 1.99 and 1. So whole number ratio will be, okay, last week also we discussed how to come whole number value, so you have to into it with 1. Okay, so it will become 1 to 1. So the empirical formula of the compound is CH2O. So molecular formula will be 12 plus 2 into 1.008 as the values are given plus 16.0, and it will become 30.026 AMU, and molecular mass given 30 AMU. So you have to just divide it and it come 1. So molecular formula 1 into empirical formula, it means same CH2O will be come here also. Hence, the molecular formula of the given compound is the same as its empirical formula, which is CH2O. Okay. Another example is here. A gaseous hydrocarbon on analysis gave the following data. It contains carbon 82.7% and hydrogen 17.3%. The mass of 132 ml measured at STP of it is 0.342. Okay. Find the molecular formula of hydrocarbon. So for calculation you have to first take given two elements there, carbon and hydrogen only. Okay, so their atomic mass is also given to us, so their percentage also we have to just calculate relative number of moles. So you have to divide 82.7 upon 12.21 and you will be get 6.89 and 7.2 respectively, and lowest value is 6.89. So if you make their simplest mole ratio, it comes 1 and 2.50, and when you make their whole number ratio, okay, so to become 2.5 whole number you have to into it with, okay, 2, and it will come 5 and 2 here. So your empirical formula of the given hydrocarbon is C2H5. So there are other examples also given. Okay, if you have to calculation of molecular formula, how can we get empirical formula mass is equal to 2 into 12.01 plus 5 into 1.008, it will come 29.06 AMU. Okay, as we know that at the STP, okay, the 1 molecular gram of substance is 22.4 liter. Okay, if you convert it into milliliter, it will become 22,400. So the gram molecular mass of the given hydrocarbon is 0.342 upon 132 into 22,400 is equal to 58.0 will become. So hence its molecular mass is 58.0. So now you can easily calculate the value of n, and 58 upon 29.6 is become 2. So molecular formula is 2 into C2H5, it means C4H10. So The molecular formula of the given hydrocarbon is C4H10. Okay, some other example also given here, so you can see them also, and if you find any difficulty to understand it, you can ask to me. Okay, or try to solve these type of question more and more related to empirical molecular formula. Okay, and empirical formula. Thank you.